Welcome back to The Deep Dive. So today we're looking at the real foundation of the AI revolution. I mean, if you picture modern AI, all these huge models and complex algorithms.
That's like a giant orchestra.
Exactly. It's this massive orchestra. But Python isn't the flashy violin soloist. It's not even the instrument. It's more like the silent, elegant director coordinating everything.
That analogy is spot on. It really is, because it gets to the heart of the paradox of Python. And today that's what we're going to dive into. We've got academic research, industry reports. We're going to figure out exactly why this relatively slow language became the dominant force in AI.
And our mission here is really to give you the full picture. We want to explain Python's role, point out the essential tools you need to know about, and, well, help you make better decisions, whether you're learning this stuff or building with it.
And we'll cover the strengths for sure, but we're also going to look at the limitations and maybe even what could come next.
Okay, let's kick off with the history. Python's been around since 1991, but its big moment in AI didn't happen right away, did it?
Not at all. It was a slow burn. The real explosion, the huge spike in adoption happened in a pretty narrow window, really between about 2010 and 2015.
Okay, so why then? What was so special about that specific window?
It was kind of a perfect storm. You had three things happening at once. First, data just exploded. Second, serious computing power, especially GPUs, suddenly became affordable and available.
And the third thing?
The third, and maybe the most crucial part, was that Python's own scientific ecosystem finally matured. Without that foundation, Python just wouldn't have been ready to catch that wave.
Right, those foundations, the pillars. Let's talk about those building blocks because they're still so critical today.
Well, the early hero was a library called NumPy. It came out around 2005, and it was an absolute game changer. It let Python handle high-performance matrix computing, which is, the mathematical bedrock of basically all AI.
And then others built on top of that.
Exactly. Then you got SciPy for more advanced statistics and optimization, and then came Pandas. Pandas became the global standard for just wrangling data. It gave you this powerful, almost spreadsheet-like way to work, but with all the power of Python underneath.
So the data management part was solved. But the real shift happened when deep learning went from this niche academic thing to something anyone could use.
That was the tipping point, the accessibility revolution. You had these incredible frameworks built right on top of those pillars. TensorFlow came out in 2015.
And then PyTorch in 2016.
Right. And suddenly, these incredibly complex models were something anyone with a bit of Python knowledge could build. Pretty much turned Python into the universal language of AI research overnight.
That's the backstory. But how do we know this isn't just, hype? What's the hard data say about where Python stands today?
Oh, the evidence is just overwhelming. I mean, look at the IE Spectrum ranking. It's a huge deal for developers. For 2024, Python was ranked the #1 programming language in the world, period.
Ahead of C, C++, C, Java, all the old heavyweights.
All of them. And the report says that climb to the top was almost entirely because of its role in AI and data science.
And that's reflected in the job market.
Absolutely.
Yeah.
You look at the big developer surveys from places like Kaggle or Stack Overflow, something like 70% of professional data scientists say Python is their main tool. That's a massive majority.
And it's not just an industry, right? It's where the new ideas are born.
Precisely. In academia, over 65% of machine learning papers that publish code publish it in Python. That means if a team in one part of the world has a breakthrough, another team can download their code and reproduce their results almost instantly. It's because of the language of science. Okay, that settles the what. Now for the why. I mean, it still feels a little counterintuitive that a fundamentally slow language won the AI race. Let's dig into the 5 core reasons, starting with the most obvious one for new users. It's just easy. Simplicity is a superpower here. You always hear Python described as code that reads like English. And research actually backs this up. The clean syntax means there's a lower cognitive load. You spend less time fighting with the language and more time thinking about the actual problem.
So it's perfect for a scientist or an economist who's an expert in their field, but not necessarily a career software engineer.
Exactly right. And that simplicity, when you pair it with reason number 2, creates this almost unbreakable monopoly. And that's the ecosystem.
Right. The ecosystem is everything. No other language is even in the same league when it comes to the sheer number of high-quality specialized tools.
It's completely incomparable. Just think about the categories. For deep learning, you have giants like TensorFlow, Keras, PyTorch, JAX. For traditional machine learning, scikit-learn is the undisputed king.
For data, you've got NumPy and Pandas. For scaling up, there's Ray and Dask.
And we haven't even touched on natural language processing with Spacey and Hugging Face's Transformers library or all the visualization tools like Matplotlib and Seaborn. It's a whole world.
And that world feeds reason number 3, right? The huge academic community.
It's a virtuous cycle. The amazing tools attract researchers, who then build more amazing tools and publish their code, often in Jupyter notebooks. It just speeds up the pace of scientific discovery because everyone's speaking the same language. Okay, now for the most critical point, the one that tackles the big criticism. Reason number 4. Python isn't actually as slow as it seems because of its integration with C, C++A, and CUDA. This is the secret sauce. This is the whole trick. Yes, pure Python code is slow because it's interpreted. But in AI, Python itself almost never does the heavy lifting.
So what is doing the heavy lifting?
The core operations, those gigantic matrix multiplications that power neural networks, they're all happening in these super optimized back-end engines written in C, C++A, and CUDA, which is the language for NVIDIA GPUs.
Okay, but let me challenge that for a second. If the real work is happening in C++A, why not just write everything in C++A? Why have Python as a middleman at all?
Because Python is an infinitely better manager. Think of it like a factory. You don't ask your CEO to be on the assembly line packing boxes. That's inefficient. You have your workers, that's the C++ and CDA code doing the high-speed labor. And you have your CEO that's Python handling the high-level strategy, the logistics, data prep, error checking, all the coordination.
But it makes development faster, even if the execution speed comes from somewhere else. Way faster. You get the easy, rapid prototyping of Python without sacrificing the raw power of the hardware. It's the best of both worlds. And that brings us to the 5th and final reason. Massive enterprise support. This just seals the deal.
It really does. All the big players, Google, Meta, OpenAI, Microsoft, they all build and release their primary AI tools in Python. When the entire industry standardizes on one thing, it becomes almost impossible to displace.
So with Python as the clear director, where does that leave the competition? Let's quickly survey the other languages out there.
Yeah, it's worth being honest about them. Take R, for example. R is fantastic, maybe even better than Python, for pure, hardcore statistical analysis. But its deep learning ecosystem is, well, it's just not there. It's very limited.
And what about the ones that promise to fix Python's speed problem, like Julia?
Julia is probably the most interesting challenger. It was designed from the ground up to be both easy to write, like Python, and fast, like C++ now. And it is fast. But its biggest problem is simply adoption. The ecosystem is tiny in comparison. Nobody wants to be the first one to rewrite decades of code.
And C++ is still the king for raw performance.
Absolutely. For systems where every nanosecond counts, C++ is still the go-to. But for research and prototyping, it's just way too slow to write and debug. You'd kill your iteration speed.
And the new kid on the block, Rust. Rust has huge promise for building secure, high-performance infrastructure. You're seeing a lot of backends being rewritten in Rust. But again, its AI ecosystem is still really, really young. The consensus is clear. Nothing else combines accessibility, a mature ecosystem, and that level of community support. All right, let's pivot and talk about the negatives. No tool is perfect. What are the major trade-offs when you choose Python?
Well, the first one is the one we keep coming back to, the modest performance of pure Python code. And this is where we have to talk about the 3 most infamous letters in Python programming, GIL, the global interpreter lock. For listeners who aren't deep in the weeds, can you just break down what the GIL is and why it's such a problem?
So think of the Python interpreter like a building with lots of rooms, which are your CPU cores. The GIL is like having only one master key for the entire building. Only one thread can hold the key and do work at a time. It's a mechanism to protect memory, but the side effect is it prevents true parallelism within a single Python program. So even if I have a monster CPU with 64 cores, Python can really only use one of them at a time for certain tasks.
That's the bottleneck, exactly. It seriously limits true concurrency. Yeah. And for scalability, that's a major weakness.
And the second big drawback is almost the flip side of its greatest strength. The ecosystem is so big it creates dependency overload.
Right. Python's power comes from these external libraries, but relying on thousands of different packages creates a massive headache for developers. I'm talking about fragmentation.
Oh, the environment management nightmare. Every data scientist has a war story about this.
They really do. You spend hours trying to figure out why your pip install broke your conda environment, or why 2 libraries need conflicting versions of a third one. It's a genuine drain on productivity.
And lastly, for the absolute biggest supercomputing tasks, Python's role as a manager can sometimes still be less efficient than a pure C++ or Rust system.
Precisely. For that top 1% of scale, you still get more efficiency by going lower level.
Okay, so with those limitations in mind, let's look to the future. What are the trends that are keeping Python relevant?
The future is definitely hybrid. Python is evolving to work even better as that high-level manager. We're seeing a huge push into frameworks like JAX.
We mentioned JAX earlier, but what makes it different from something like PyTorch?
So JAX takes a different approach. Instead of running code line by line, it lets you compose functions that can be compiled and heavily optimized ahead of time, especially for GPUs and other accelerators. It gives you Python's ease of use, but with performance that gets much closer to what you'd expect from a compiled language. So it's doubling down on that hybrid approach. Python on top, something really fast underneath. It is. And you'll see more Python plus Rust or Python plus C plus backends. Development logic stays in easy-to-write Python, and only the absolute most critical parts are written in a faster language.
And Python's also leading the charge in making AI even more accessible, right, through AutoML.
Absolutely. Tools like AutoKeras and AutoSclearn are automating the most tedious parts of machine learning. And for the giant models we have today, the LLMs, Python is the indispensable glue that manages all the complex data pipelines and embedding lookups around them.
So despite some very real challenges, the consensus seems clear. But what does Python have to do to stay on top for another decade?
Well, the big one is they have to do something about the GIL. The community has been trying for years to find a solution that allows for true native parallelism. That's priority number one. And priority number two is just simplifying dependency management. That fragmentation headache needs a real solution.
And it has to keep an eye on the competition.
For sure. The pressure from fast, modern languages like Julia and Rust is healthy. It forces Python to keep evolving, to keep getting better at its job as the ultimate coordinator.
So let's bring this all together for you. The core takeaway from all the research is that Python's dominance isn't an accident. It's not about its own speed. It's about its unmatched ability to act as the ultimate bridge.
It's the bridge between complex algorithms, powerful hardware, and the need for reproducible science. That's why it's the standard, and why it's going to remain the preferred language in AI for a long time to come.
But as we wrap up, maybe the future challenge isn't really about the tools themselves. Maybe it's about the people who use them.
That is the final thought to leave you with. The real test for the next generation of AI isn't just making better tools, it's making sure the next generation of scientists and engineers actually understands the math, the statistics, and the core concepts that are running underneath these wonderfully simple Python libraries they use every single day. Because that's where the next true innovation will come from.